Too many things for my poor brain to keep track of. Okay, so the topic for today, we are still studying inheritance. On Monday, we did sort of a introduction to inheritance. There's one more thing we need to talk about with respect to inheritance, and that is virtual functions and polymorphism. Don't let that word scare you. It's a big fancy word, but we'll be talking about it a lot, and I think it'll become clear. So we've been studying object-oriented programming, and in order for a language to be considered a object-oriented programming language, there are generally three features that are expected. So the first one is encapsulation. That is basically, you could think of that as being the fact that you can make some of the members of your class private, right? So you are encapsulating those members so that functions that are not part of the class cannot access those members. So that's encapsulation. That's one thing that's required. Second thing that's required is inheritance. That's what we're talking about now. And then the third thing that's required is polymorphism. And so that's what we're going to be trying to pin down today. So generally speaking, or I guess maybe to define it loosely, polymorphism is the ability in a programming language to use, to have more than one function with the same name. Okay. Well, we need to be a little more specific than that, though, because we've already been doing that, right? We can have different functions with the same name as long as the signature of the function of the functions are different, and that's called overloading, right? And we've been overloading for most of the semester now. So that's one way in which we can have different functions with the same name, but in this context, we're actually referring to something more specific than that. Okay, we're referring to when there is a function in a base class and a function in a derived class that have the same name, and how it gets decided which one is going to be executed. And there's a couple different ways to do that. Okay, so this second situation here is called redefining. And in this case, what we have is we have different functions with the same name, one in the base class, one in the derived class. The compiler decides during compilation which function to call. Okay, so that's called compile time binding or early binding. So that word binding just means connecting the function call with the actual function that is going to be executed. Okay, so probably if you're listening to this for the first time, you're thinking, okay, that's kind of weird. When else would that happen? And why does it matter? And that's okay. That's what we're going to be talking about for the rest of the lecture, for the most part. So just putting that out there for now as a definition, and we'll do some examples in a minute. So that's called redefining. And then there's a third method, which we call overriding. And it's the same thing as number two, different functions with the same name, one in the base class, one in the derived class. But the decision about which function to call occurs while the program is running instead of occurring while the program is being compiled. And so that's called runtime binding or late binding. So there's the definitions. And so when we talk about polymorphism being a requirement for a language to be considered object-oriented, we are referring to this third category, right? If a language only provides the first two methods and doesn't provide this third technique, it would not be considered an object-oriented program. Okay, so I understand that that may seem a little fuzzy at this point because you may be wondering what difference that makes and some details like that, but hopefully you at least have a handle on the definition. Okay, any questions so far? All right, so what I'm gonna do is I'm gonna show you 3 examples now that illustrate situations where this matters. So it matters whether the decision about which of those 2 functions to call occurs at compile time or at runtime. So let me pull up the first example here. Here's my first example. So sorry, give me just a second. I have something I need to take care of. Okay, so yeah, go ahead and stare at this example for a little bit. I want to just say that there are several things here that may look strange to you because it's not how we usually do things. So I just want to say, try not to let that throw you off too much. Don't let it intimidate you or make you feel like you don't understand what's going on. We're just doing things that are a little strange, but that should be okay. So for example, we're putting 3 classes all in one file. We don't usually do that. We are defining the function right inside the function declaration instead of defining it separately. We don't usually do that, but that's okay. Now we're just defining the function right inside the class, not a big deal. And the third thing is each class only has one function, has no data members. So that may seem strange, but just accept that it's fine. There's nothing wrong with this. They're kind of useless classes, right? There's not much use of having a class that doesn't have any data members. Well, there could be, but it may feel that way. So just go with it, and hopefully that won't be too confusing. So let's take a look at what's going on here in main, right? I'm declaring one object from each of those 3 classes. I guess I should just make sure we notice that both of these 2 classes, derived 1 and derived 2, are derived from the base class. Okay. So we've got we've got 3 objects being declared here, 1 of each of those 3 classes. I'll make it so that the whole everything, look at everything at once without me having to scroll up and down. Okay, and then we've got this other variable here, which is declared as a pointer to a base class object. The interesting thing there is that if you declare something to be a pointer to a base class object, that variable, that pointer variable, is also allowed to point at objects that are derived from that base class. So that sort of goes back to the thing where we said in C++, a derived class object is a base class object, right? So that means that in many cases, we can substitute a derived class object where C++ was expecting a base class object. Okay, That's not a general purpose rule for all situations, but in some situations, which I will show you, that works. Does that make sense? The part about P being allowed to point to either base class objects or derived class objects. No questions about that. Okay. So here's what's going on in main. I'm saying, okay, make P point to B, which is a base class object, and then call the vfunc function using that object as the calling object. Right? And then I'm saying, okay, let's change that up. Let's make P point to the derived one class object instead. And then let's call vfunc again using that derived one class object as the calling object. And then same thing again, right? Okay, now we're going to make P point at a derived two class object. And then we're going to call vfunc using that derived two class object as the calling object. So I want you to think for a second about what you would expect the output to be here. Okay, so I kind of explained that right here with this comment, right? P arrow vfunc is just saying, okay, take the object that P is pointing at and use that as the calling object and call vfunc. Does that work? Okay. Like dot for pointers. Yeah, so I mean, I guess you could, the one way to say it would be is if P was actually an object, then you would just say P dot vfunc, right? But since P is a pointer to an object, instead of saying P dot vfunc, you say P arrow vfunc so that you dereference the pointer. Okay, so anybody want to just tell me what you would expect the output to be here? You don't have to, actually type out the whole thing, but just explain maybe. The base class vfunc. Okay, for the first one. So when I call vfunc, that time it's going to say, it's going to print the base class vfunc. What about here? So I guess I will tell you what you should probably be expecting here. What we really would usually or typically want to have happen here is, well, P is a pointer to a derived class object, right? So from our perspective, from the programmer's perspective, what makes sense is that derived ones vfunc would get called, right? And then at this point, P is a pointer to a derived two class object. So what makes sense here is that derived twos vfunc would get called. So that's a pretty critical observation. Hopefully it makes sense why that would be sort of what you would naturally expect. But as you could probably tell from my tone of voice or whatever, that's not what we get, right? It calls bases vfunc no matter what. So let's talk about why that is. It turns out that if you think about it, when I get to this line of code right here, and when I'm compiling the code, so this is a case where you really have to be clear about the two-step process, right? There's a step where you are compiling the code, and then after the code is compiled, you execute that machine language program, right? You can't do them sort of at the same time. You can't sort of be running the program while you are compiling it. So It turns out that during the compilation process, when I'm about to compile this statement on line 37, the compiler has no way of knowing what P is pointing at, right? That only happens, making P point to derived one, that only happens when the program's running. So the only thing the compiler can do at this point is it looks up P to see what it is. It sees that P is a pointer to a base class object. That's how we declared it, right? And so it calls the base class objects vfunc. Okay. What you're going to find out as you continue working with this stuff is that that is pretty much never what you want, right? In the code we've written right here, it's okay if it's not clear at this point, because this is such a contrived example, but take my word for it. In a real programming situation, when you get to a line like this, what you want is you want it to call the D1's vfunc. Okay, so basically what I'm saying is, darn, what's happening here is the wrong thing. The way to fix that in C++ is we say, okay, instead of deciding which function to call while you are compiling this code, here's what we're going to do. We're going to just postpone that decision until we're running the code. So you can imagine that what the compiler is going to do is it's going to say, okay, I can't decide yet which function to call, so I'm going to put like a little if statement in here. And this is not technically what happens, but the concept is, in my code that I am generating here, I'm going to have a little if statement, and it's going to say, okay, if at this point while the program is running, P is pointing at a base class object, then call the base class object's vfunc. Else, if while the program is running at this point, P is pointing at a derived one class object, call derived one's vfunc, and so on. I won't repeat that big long sentence for derived two. So we're saying, do this at runtime instead of at compile time. Make the decision or do the binding at runtime instead of compile time. Okay. The way we do that in C++, the way we tell the compiler to do that, so put the word virtual in front of the function definition here in the base class. Just adding that one word is going to make it so that instead of early binding, I get late binding. And that fixes our problem. Okay. Any questions about that? Anybody want to make a comment, ask me to clarify anything? Why virtual? That is a great question. I'm not sure. I think, I'll just take a guess here, okay? I think it has to do with the fact that we're not actually binding the function call to an actual physical function at this point. So in a sense, we're binding it to a virtual function that will become an actual physical function later during runtime. That's just a guess. I've never actually thought about why the word virtual is what they decided to use for that. That'd be a great thing to Google. Okay, any other questions about this? And so I guess I just want to say a lot of what I'm doing here is, it's important at some point anyway to really understand at a deep level what polymorphism is. Polymorphism is this ability to do the binding or decide which function is going to get called at runtime. If that doesn't make any sense at all right now, that's probably okay. It's probably not going to bother you. It's just going to mean that if you're using inheritance, just put a virtual in front of your functions in the base class, and you're fine. here's another way of putting it, okay? There may be others, but to my knowledge, in fact, there are probably others, but to my knowledge, C++ is actually the only language that even gives you this choice. Right, that's a great question. For example, in Java, there's no choice. You just, everything uses polymorphism, and there's no way around it. How come it's not the default for C++? That's another great question that I do not know the answer. I don't know why they chose not to make that the default. The only thing I can guess is that that's the more fundamental thing, right? When you use virtual, you are doing something that's more complicated and it's out of the ordinary. So according to the C, I'm just guessing here again, okay, but according to the C++ way of doing things, you just do the ordinary thing if the code is just ordinary. And then if you want to do something that is unordinary, then you add another word to it to make the unordinary thing happen. So, and again, I suppose, I mean, those are interesting questions, but I guess they don't really affect whether we understand what's going on here or not. The only thing I would say, you know, if I'm just sort of grasping at straws and trying to think of a reason why someone would ever want to not use virtual here, the only thing I would say is that there is a very, very, very slight impact on running efficiency, right? Because if you use runtime binding, what that means is that every time this function is called, you have to perform a little if statement to decide which function is going to get called, right? But that little tiny hit in terms of efficiency is a very small price to pay for having it do the right thing. Okay, anything else we want to talk about on this example?
Yes, excuse me, I do have like, I'm a little bit confused about like runtime and compiling, like.
I'm sorry, I think I missed like 2 or 3 words from your question.
Can you hear me now?
I can hear you, yes.
I said like I'm a little bit confused about runtime and compile time.
You're confused about. Okay, that's an important thing to take care of. I mean, so are you confused about, well, let me just assume that there's somebody in the class will be confused about just like even what I mean when I say compile time and what I mean when I say runtime. So when I want to run this program that we see in front of us, the first thing I have to do is I compile it, right? And so the compiler reads this code, translates it into machine language, and creates an executable file. That process, there's no running of the code happening during that process. All that's happening is I am translating these C++ statements into code that will run on the machine. Then, after that step, that's when I actually run the executable file. So when I'm doing this step of compiling, when I'm doing the step of translating this code into machine language, there's no way during that process to know what P is pointing at, what kind of object P is pointing at here, because that's something that only happens while the program is running. Okay, and that might be, you might be thinking, well, why doesn't the compiler just do a little analysis and look at the statements that came before and try to figure it out? Well, it turns out that that's basically an impossible task. Basically, the only way to do that consistently would be to actually run the program while you're compiling. So we just don't do that. All right, so I don't, well, actually, let me just throw one more thing out at you. So when I showed you this example, the first thing I did was, and I realized this is different from the setup you guys are using, which is fine. I just haven't been able to get Xcode on my computer because I don't have enough memory. But in this case, actually, there may be some advantages to using the command line instead, because you get to see the different steps, right? The first step is when I say G++, that means that's where I am saying, translate this C++ code into machine language and put that machine language into a file named a.out. Okay, then the next step is when I say, okay, now I've got that executable file named a.out, now go ahead and execute that file. Okay, so during this, what I'm saying is during this process, there's no way to decide correctly which function to call. So that has to happen during the run of the program. So if that didn't answer your question, let me know, or maybe articulate it differently.
It did.
Okay.
It did. Thank you.
Excellent. All right. Anything else? Anything else with this example? Okay. So going back to our little notes here. Turns out that there are three situations. So this is kind of I call this the lecture of threes, right? Everything is coming in threes. There are three situations in which it matters whether early binding or late binding is used. And what I just demonstrated to you is the first one. A program has a variable declared as a pointer to a base class object, but sometimes it points at derived class objects. Okay, so hopefully, if you're listening at all, it makes sense that that sentence describes the example we just did. Anyone want to take another look at that example now that you see the sentence there? Okay. So I'm going to uncover the second situation in which it matters. And really, it's kind of the same as the first one, right? It's just if it's declared as a reference, as opposed to being declared as a pointer. In both cases, the point is it's a memory address, right? But just to show you this, let's look at another example. And in this case, the key point here is that I am using a parameter that is a pass by reference parameter of type base. And so what that means is that when I call that function, I can send it a base class object, but I can also send it a derived class object. So inside this function, at compile time, when I'm trying to decide which vfunc it is I'm supposed to call, the compiler has no way of knowing what R is a reference to. Is it a reference to a base class object? Is it a reference to a derived 1 class object? Is it a reference to a derived 2 class object? We don't know, or the compiler doesn't know during compilation. But if I postpone that decision until runtime, then that decision can be made correctly. So anybody need to stare at this code longer? I know that when I take coding classes, I hate it when instructors just flash code on the screen and I don't have time to digest it. So feel free to tell me to stop.
So for the second example, how would you postpone it until the runtime?
Well, we'll do the same thing, which is we put the word virtual in front of the function definition in the base class.
Oh, okay. So you do the same thing and it solves both problems.
Yes.
Okay.
Yeah. So, right. So I'm not, we're not, I can see, I think where you were going was, okay, this is a different problem. So there's going to be a different way to solve it. Right.
Yeah, I did
but-
think that.
But this is more just, I'm trying to show you all of the different situations in which the same solution is applied. Okay, so hopefully you've had a chance to look this over. What's going to happen when we don't have virtual there? Hopefully you can guess. Oops, that's the wrong file. It's going to just always call bases vfunc. Okay, but if I put the word virtual here, I get the desired output. Okay, any questions about that? Okay. Third situation is a little more subtle. I think it should make sense, but I guess I'm done with this. Right. Okay. If a base class function calls a function that is defined in both the base class and the derived class. So you can imagine you've got a function in the base class. That function f calls function g. Function g is there's a version of function g in the base class, but there's also a version of function g in the derived class. So how does the compiler know which of those two to call? Because it has no way of knowing what the original calling object was. All right, so let me try to give you an example of that. So this example has the potential to be a little confusing. Oops, sorry, this is wrong. I wonder if I can just, oops, Control Z my way out of it. That might be it. Okay. All right, so we're going to take some time and go over this code. Please just let me know if you need me to slow down or repeat or just stop for a second so you can stare at the code. Basically, we are simulating a drawing program. And but so instead of actually drawing things, we're just going to use cout statements to explain what it would be that we would have drawn if we were actually drawing things. So hopefully that stretch won't be the thing that nature breaks, whether you understand what's going on here or not. So let's look. We've got a class called figure. Figure has a constructor which just prints out the words constructing a base class figure object. It has a function named draw, which just says, prints out the statement drawing a base class figure object, and a function named erase that just prints out the words erasing a base class figure object, and then a function named center. And the function named center calls erase to erase the figure, and then calls draw to draw the figure back again. Anybody want to ask a question about any of that? So the key thing to notice here is that this function named center is calling a function named erase and a function named draw. And what we're going to see is that when we derive a class from this figure class, that class is going to need to provide its own draw function, right? Because the figure class isn't going to know how to draw a box and a triangle, right? I'm deriving these two classes, triangle and box, from the original class. There's no way to include that information in the base class. The derived classes are going to have to provide a draw function that performs the task of drawing that particular kind of figure. So inside the class, inside the box class, which is derived from figure, there's going to be a draw function that correctly draws a box class, a box object. And there's going to be an erase function that correctly erases a box object. Okay, so the point here is that inside center, when we call erase, if the object that called center in the first place was a figure object, then we want to execute this function. But if the object that called center in the first place was a box object, then we want to call this function, right? If we call the center function with a box object as the calling object, and it turns out, and the figure version of the erase function gets called, it's not going to correctly erase the box. Okay, so I did all of that talking about the box class. It turns out that in the actual example here, I'm going to be using triangle instead, but hopefully that's not too confusing. And basically triangle is exactly the same as box, just replace the word triangle with just replace the word box with the word triangle. Okay. Anybody need me to repeat or slow down or let you stare at the code a little longer? We haven't talked about the client yet. Okay, so let's talk about the client. In the client, I am declaring a triangle object. I'm calling the draw function from the triangle object, which is fine. There's no ambiguity there. And then I'm going to call center using a triangle object as the calling object. So that's when it's going to get tricky. I'm calling center with a triangle object as the calling object. When I get to the erase function here, there's no way for the compiler to know that it was a triangle object that called this. And so it's just gonna call the erase function of the figure class, which is gonna be wrong because the erase function of the figure class doesn't know how to correctly erase a triangle. Okay, here's the output we're looking for. This would be the correct output, right? Centering a drawing by first erasing it. And so then it should say erasing a derived class triangle object. But what's going to happen is it's going to say erasing a base class figure object because we are making the decision about which function to call at compile time. So if I run this right now the way it is, without virtual, you'll see that down here, centering a drawing by first erasing it, and then it says erasing a base class figure object, but that's wrong. We want it to be erasing a triangle object. So the way we fix that, as you know by now, put the word virtual in front. Run it again. and we get the correct erasing a derived class triangle object. Okay. So that's an example of early versus late binding matters when a base class function calls a function that is defined in the base class and also in a derived class. Any questions about that? Okay, so I'm just guessing that this example may be difficult to follow when you're sitting in front of your computer listening to me go on and on about it. So I just want to really encourage you to, spend the time and look this over and try to figure out for yourself what's going on with it. I'm thinking that if you just spend, 20 or 30 minutes staring at this, it should start to make sense. The other thing I'll just say at this point, this is a digression, but I think you're going to like the assignment, the lab for this topic. It's usually the favorite lab of the semester, not only because the subject matter is interesting, but the lab is set out in sort of a step-by-step process. So it's a little more controlled and you just have to follow the steps. And there's not a whole lot of creativity involved. So anyway, something to look forward to. If you find yourself getting super stuck on lab 9 or 10, I think this is 11, right? Anyway, if you find yourself hopelessly drowning in one of the previous labs and you need to take a break, it might be fun to actually just go do a little work on this one. Okay, so I think I am done talking about polymorphism. There's just one more thing we need to hit on in this section. And that is, let's say, hypothetically speaking, we decide that there's never actually going to be a figure object, right? Whenever we declare an object, it's always going to be either a circle or a box or a triangle or a trapezoid or a polygon or whatever, right? But there's no need to actually have objects of type figure. So what we're going to do, so one observation I would make is that in that case, we could just delete the draw function and the erase function from the center class. They're never going to get called, right? However, there's a better solution. The problem with that solution is that it doesn't tell the derived class programmer that they have to provide a draw function or they have to provide an erase function. And that's basically what we're saying here, right? If we're the programmer writing the figure class, what we're saying here is, in order for my class to work, any class that is derived from this class must have an erase function and must have a draw function, because the center function calls those functions. Okay, this is a very, very common situation in inheritance. The way that we enforce that, and the compiler actually enforces this, is we can get rid of the body of these functions, but then at the end of each function, we just put an equals 0 semicolon. Equals 0 semicolon. And that's just sort of the magic incantation that tells the compiler that this is it's called a pure virtual function. Okay, and that just means any class that is derived from this class must provide a draw function and an erase function. If it doesn't, you're going to get a syntax error. Okay. And it might be interesting to see what comes up if we try that. But so any questions about that? And, well, so one more just piece of terminology. In a class that has at least one pure virtual function, it's called an abstract class, right? And that should kind of make sense. The reason it's called an abstract class is that no matter is that you're not ever going to have an object of this type. The only purpose of this class is to have other classes derived from it. Okay, so and the advantage in this particular case is that now when I define my triangle class, I don't have to provide a center function. It's already done for me. When I said public figure, so in other words, when I said this class is going to be derived from the figure class, I automatically got this center function, and so I don't have to write it for myself. Okay. Any questions about any of that? It's all pretty cool. If you understand what's going on here, it's a very cool system. Makes a lot of sense. Hopefully when you're working on the lab for this, it'll give you even more of a sense of what's going on. Anybody want to ask any questions, make any observations? Okay. So I think I'm done with that example. Basically, there's just one more thing to do with respect to inheritance. First, let me just make an observation that inheritance is sort of a unique topic in our class, in that pretty much everything we have done everything I have done to try to teach you about inheritance has been just little toy programs that aren't really very big and don't really do very much. And with inheritance, it's actually pretty hard to get a decent example that actually shows inheritance at work, because it requires so much code just to have an example that shows you the power of inheritance. So what I have done is there's a sort of a case study. In other words, a more extended example of inheritance that I copied from one of the data structures textbooks that I have used in the past. And it's at the end of this lesson. And so you should go there and take a look and study it at some point. I will talk about it just a little bit right now. Yeah, let's do that. So we're on lesson 18. Okay, so and just to give credit, the following example is from this textbook by Michael Main and Walter Savage. But it's I love this example because it really demonstrates many, if not all, of the sort of different nuances of ways you can use inheritance and polymorphism. So the project we're going to look at has 5 files. There's a base class, which is a game class. The idea being that if we want to write a class for any game, instead of doing everything from scratch, we can derive it from this game class. One of the most important things that this game class takes care of for me is there is a function in this base class that can actually be used to figure out, it's a little AI, right? It figures out what the best next move is for the computer, which is very complicated and advanced, right? So I don't expect you to understand that algorithm at all. What you need to understand is that that algorithm has been provided in the base class. So when I write my derived class, I don't have to worry about that. It's done for me already. Okay, so in this example, so we've got two files for the game class, the header file and the implementation file. And then we are actually implementing the game of Connect 4. And I don't know how many of you are familiar with Connect 4, but I have a link here to the game itself in case you want to play around with it to understand what it actually is. Probably important that you understand what the game is before you try to understand the code. And then of course the fifth file will be the client file. And the client file, yeah, you can see there's a lot of code here, right? But the client file doesn't do much, right? It just play the game. So here's the statement that says play the game, and then print out a message saying who won, and then see if you want to play again. Okay, so the client doesn't actually do much. It just calls the play function. So I do want to I'm actually curious if this link is still any good. Right, so here is a Connect 4 game. And so basically, apparently in this game, the computer is blue and I'm red. So I'm gonna, probably some of you have played this before and are much better at it than I am. So I might just go here. Now I have to block. So the objective is to get 4 in a row, either horizontally, vertically, or diagonally. And I have to admit, I usually end up losing this game. So anyway, you get the point. Hard to stop once you start. Any questions about the game itself? Okay, so let's look at the base class. And let's make this a little bigger. Okay, so I'm just kind of looking, so think the way you should be looking at this is you should be thinking about, okay, I want to write a class called Connect 4 that is going to be inherited from this class. Let me see if I can understand what I need to do. I want to understand about how this base class functions, but I don't need to know or understand the actual implementations of the functions. I just need to know what they do so that I know how to use them and I know what I need to provide in my class. Okay, so I've got this enum, which we haven't covered, but hopefully you can pretty much figure out what's going on just by looking at it, right? What it means is that I have a new type named who, so that's a type. You notice the syntax is actually a lot like classes and structs, right? I could say class and then the name of the class, open curly brace, close curly brace, semicolon. Same thing, except it's enum. The name of the new class is who. And then what this is it's just simply a list of all the different possible values that variables of type who can have. Okay, so if I declare a variable of type who, and say X, then I could say X gets human, or X gets neutral, or X gets computer. So here's my constructor for the base class. I'm just going to say move number gets 0. Here's a destructor. Let's not worry about that for now. I'm just kind of looking this over and trying to get an idea of what I need to know in order to write my class, right? Okay, so here is a public member function. The play function should not be overridden. Okay, so I'm not going to have to do anything for the play class when I write my derived class. It plays one game with the human player moving first and the computer second. The computer uses a fancy look-ahead algorithm to select its moves. The return value is the winner of the game, right? So the play function returns a variable of type who, which means it returns a variable that's going to be either equal to human or neutral or computer, and that's the winner of the game. Okay, so that's a function that should not be overridden. Now we have some functions that are that may be overwritten. Okay, so there's going to be a definition for all of these functions when I look at the implementation file for this base class. And when I write my derived class, I may decide that that function is good enough for me, or I may decide that I need to write a specialized function for my particular derived class. Okay, and so it's nice that these functions are categorized like this, because that's pretty much how things are going to go in the real world. You're going to have member functions of the base class that fit into one of these categories. Either do not overload it, do not override it. You may override it. And here are a couple that must be overridden. And in this particular base class, it says the overriding function should call the original when it's done. If you have when you have time to look at this, you'll see what that looks like. But so here's two functions, make, move, and restart, that must be overridden, because there's got to be more to making a move than just what we're going to have in the base class. So the derived class is going to have to provide more information about that. And then here's another, yeah, go ahead.
Can you give an example of calling the original when a function finishes?
Yeah, I'll have to skip ahead a little bit, but the way we would take a look at that would be, basically it just means that in my Connect 4 class, I'm going to have a function named restart, and it's going to have some code, and then the last statement in the code is going to be restart, and so it's going to call this one. But so we can look at that.
Got it.
I'm looking for a function named restart in my Connect 4 class. Lots of code here, as you can tell. Here's the function named restart, right? So here's the code that I'm providing in my derived class as part of the process of restarting the game. And then once I finish that, I'm required to call the restart function from the base class. And there's how that looks.
Got it.
Okay. And then just one more to talk about, one more category of functions to talk about in the base class. And that is the pure virtual functions, right? These are functions that are not provided in the base class at all, but the derived class must provide those functions in order for things to work. Okay. And then we've got private data members. We've got move number. Search levels is indicating how sophisticated the AI algorithm is going to be. And then here's some private functions that are not used. The derived class doesn't need to know anything about these. Okay. Okay, so I'm kind of thinking that if we get into this too much more, we're going to run out of time. So we may just stop there. Let me just say, I'll point out the code that you don't need to look at very much, right? This function here, eval with look ahead, very complicated, very advanced, probably something you might write in CS 3.15. Here you see that the eval with look ahead function is calling itself. So lots going on here. I would not try to understand what's going on inside. Just read the description so that you know what it does. Okay. Eval with look ahead. Was that a private? That's a private function. Anyway, so I really strongly recommend that you just set aside an hour sometime to stare at this code, try to figure out for yourself what's going on with it. If there's some stuff you don't understand, shoot me an email. But I think it'll help a lot in terms of just understanding how all of this inheritance stuff works itself out in a real example. Anything else that you want to talk about? This is all in the lesson, which I will post as soon as we're done. Okay. In that case, have fun in lab, and I will see you on Monday.
Thank you.
Thank you.
Thank you.